Welcome. Thank you for tuning into my talk. My name is Lukas. I'll be your host for the next 15 minutes or so. Today I want to take you on a journey on how a small software company from Graz manages to run and maintain hundreds of servers in the cloud infrastructure for, in our cases, a high number of customers. And nowadays, software isn't just what you see on the screen. When you take up your smartphone and open an app, there are dozens of servers in the background, which you only notice when they are not working, because when everything is working, you're happy. And so today I want to talk about the magic behind this software that you see on the screen. Before we get drowned into some technical details, let's start our journey at who we are. I am Director of Operations and former Scrum Master at a company called Denovo. My work mostly consists of supporting the development process in our company and growing our agile team. And as our team evolved, my work shifted to setting up, optimizing the complete development pipeline at our company. I am based in Graz, but we also have an office in Athens in Greece. Both teams share some projects. They also have their separate projects. And yes, you can see the Acropolis from outside our office, so it's not cheating out there. We also engage in some new work trends, as we call them, or as the industry calls them. We also do some workations for our staff. So you can travel to Greece or to Athens, work together with the team in Athens, and enjoy the country outside of work. So let's continue with the question, what are the teams doing there and in Graz? Both teams focus on building, operating, and maintaining customized software solutions. These range from mobile apps to web applications and even some desktop apps. And we mainly build those apps for business digitalization process. So whenever they have a manual process or an analog process or writing for paper or on paper, you can replace this process and make it digital. And we do this for our customers, which are mainly in the circular economy. In other words, this is the recycling industry or waste industry. And this is not exclusively in the waste industry. We also have some B2C customers, so end customers. All our management and the development team are organized in an agile process. So if you're familiar with the term Scrum, this is kind of our blueprint where we model our process after. But we don't only work after an agile process, we also bill our customers in what's called agile fixed price contract. I won't go into detail, but if you're interested in the topic, go to our website, download an example of our contracts, and then you can see how we are doing it. So within this process, we do consulting for our customers, we do the development for our customers, and we also do the operations of the products that get out of the development. So we support our customers from the initial idea that they have to growing this into a product and to get the product in the hands of their customers. As a result of this, we have a quite strong relationship with our customers, which allowed us to grow from a 4 to 5 people company to a company that now has 25 employees and is spread over 2 locations. But this growth comes with some challenges that I will talk about now. I have some statistics for you, because numbers always count. We currently are running over 250 cloud instances. It can be bare metal instances or virtual instances, which spread out over multiple cloud providers. So we are not limited to serving on AWS. We also host some projects for Heroku, for example. The plus at the 250 should indicate that I can't give you an exact number because there are also some auto-scaling projects. So servers are started and stopped whenever needed. And if you look at the other numbers on the screen, If you're familiar with Scrum, you also know the term user story. If not, just consider it as a feature. So we developed over 5,000 features, and to manually test them wouldn't be possible. So we also needed to move our testing environment into the cloud and to automate it. And if you compare the other two numbers, so the 25 employees with the 35 projects that we do in a year, you will see that this is kind of an imbalance, so nobody can have the complete technical overview over all the projects. So we also need to highly automate things to keep us into the development process. These numbers also lead to some problems that we faced, and we had some specific goals in our operations process. The first one is that no single person should have the complete knowledge of all projects, because this wouldn't be possible with these numbers. So we needed to modularize everything. First up here is we need to modularize our configuration for the projects, because setting up 35 projects a year would be a tedious task, and DRY stands for don't repeat yourself, but setting up 35 projects a year would be a lot of repetition. So we needed to modularize the configuration first. We also had to make the deployments reliable, because we can't rely on a single person to deploy one project. Every developer in our company should be able to start a deployment and to verify that it's gone through. And the last point up here, we needed to learn the hard way. We had some instances running in the cloud, we paid for them, but we didn't even need them. So in the future, we had to build a system that also cleans up after we are done with our development work. From these requirements, we formed 3 principles. And these principles apply throughout the operations process and the development process. So before I give you some technical details, let's go over these 3 principles first. The first one is a setup must be reproducible. As I said, we have 35 projects. We need to reproduce them. And another important part is if something goes wrong, we need to fix it. And we don't wait for a developer that knows that project. We need to fix it right away. The second one, support and collaboration, is also about our developers. So we don't have silos of these guys are responsible for operations and these guys are responsible for development. Everybody gets their hands on everything. So the third principle here is we need to assess our security issues, because software needs maintenance, exactly like a car, for example. You need to take it to the service, and this also applies to our software. So we are not a company that ships a software and says goodbye for it. We take responsibility and assess security issues, for example. So now let's give me some technical examples for each of these principles and how we are doing it in our company. The first one here was we require reproducibility. And we do this with first containerization. So every project that we deliver needs to be built into a Docker container. Docker is just one virtualization tool. You can choose any other, but the key thing here is containerized. What this gives you is you can pack all your dependencies into this one container, and they stay the same in the testing environment, they stay the same in the development environment, and they also stay the same in the production environment. This eliminates a wide range of errors that are normally seen when you deploy your system where another version is running. It works on my machine, but it doesn't work on the server. You can go around this with containerization. The second example here is put all your infrastructure descriptions into code. We use a tool called Terraform. Terraform uses a declarative description of your infrastructure. And when you run Terraform over this description, Terraform finds out what you need to change in order to get the infrastructure in the form that you want to. So for example, stop or start a server when needed. On the right side, you can see such a configuration file, which is just a screenshot from an actual project of us. The upper half, where you can read module API, this is the complete configuration that a developer can enter to start a server, to start an application that comes out of a Docker container and to run it in the cloud. Here, for example, it's an API that runs on Heroku. If a developer decides, no, I want to run it on AWS, you just include another module, use quite the same configuration here, and you run it on a different cloud provider. Let's add a database to the mix. This is the bottom half of the screenshot. Just add another module, and you're done. Terraform finds out what you need to do in order to run it in the cloud. Next, I want to talk about the separation from the build process and the deployment, because we looked at the containerization, which is kind of the build process, and we looked at Terraform for using, for building up our cloud, and now we need to marry them together. And this is what we do in our cloud infrastructure. So on the left side, you see two Git repositories. The upper one is the description of the cloud environment, so our Terraform configuration, and the lower one is the code of the project itself. As you see, the process is quite the same for both. You check them into Git, you run it through a CI/CD. In our case, it's a GitLab CI/CD. And for the infrastructure, Terraform builds up the AWS or Heroku services. And for the project itself, it executes the test, it builds the Docker container and gives it into the registry. We have a server running, we have a software. The only thing that we need to do is run another job to push the Docker image to the appropriate EC2 instance, for example. So this is our cloud infrastructure that we rely on. This gives us reproducible results. So we can, for example, deploy an old version on another server just to test it out. We can do rollbacks of the complete infrastructure, because also the source code of the Terraform description is versioned. So if anything goes wrong, we just go back, deploy it again, and there we go. First principle done, yes. Second principle, support collaboration here. So I'm not a fan of the words or the acronyms DevOps or DevSecOps, but the principle behind is don't silo up into two departments, get the programmers to do some stuff of the operation guys and get the operations to work together with the developers. For example, operations needs to know about the project as early as possible in the process to prepare for the servers. The second point here is inner sourced infrastructure. You might ask what this is. It's kind of a newer term. It's an open source approach to some tools that use inside a company. I already talked about this version declaration of the infrastructure. Let's consider it as an open source project in the company. So every developer can make a pull request, can change the infrastructure. You run Terraform over the pull request. You check if this would do the appropriate things in the cloud. And when you merge the merge request, the Terraform pulls out in the new configuration on the cloud providers. Kind of the open source process, but in the company. And as we encourage that the developers also participate in the operations process, we modularized the configuration, for example, for our CD pipelines. And this is the complete screenshot of the configuration of one project for the pipeline. And just by switching out the included files here, you can set up the pipeline as needed. For example, include a development system, include a test system, or if you want to include a staging system, just include a file that's written here and you're good to go. As I said earlier, the developer can also decide to deploy to AWS. In this case, we have included here the Heroku files, but we can switch them out to AWS files. and the developer doesn't need to know what's going on behind all those files, but he can operate the servers behind them. So developers and operation engineers work together, and developers can also go to operations engineers and say, hey, I need a new feature here, let's change this. And they also work together in this direction. The third principle that I want to talk about was always assess your security issues. The most obvious part, which I won't go into detail here, is run your tests. Don't run your tests locally, run them in the cloud. This is kind of a simple thing that you can do. And the tests shouldn't be there for blaming somebody that somebody broke something. They should be there to have confidence that everything is working as you do changes. The second thing we do is we introduced regular cloud audits. So some things can be monitored automatically, but other things need to have a look from a person, which also is kind of mixed together with the third example here. But what I wanted to show is our customers that order cloud audits from ours get a report afterwards. And this is kind of, to get back to the car example, this is kind of a document that states you're up to date or you have to do something in order to fix your architecture. And as I said, the third point here is include the expert knowledge. It might be that there is a vulnerability which the internet says this is super critical, but it doesn't apply to your project. Or otherwise you have a minor vulnerability, but it affects your project in a great way. So make use of the expert knowledge that you have in your company, and as I mentioned before, get the developers together with other persons and use that combined knowledge. So let me summarize what we have found. We have those three principles, and I gave you technical details to every single one. For example, the reproducibility issue, do containerization, put all your infrastructure descriptions in code, and separate this build and deployment process and get your stuff working together, which leads to the second principle. Blur the boundaries between the silos, get people together and work together. Maybe apply this open source process in your company. Let the developers work together with DevOps engineers by just writing their source code and reviewing them in merge requests. And try to modularize everything, your pipeline, your configuration files, everything. And when it comes to security, take it seriously. Do automated testing as far as possible. When not possible, do manual audits in person and let a person assess if it's critical or not. To be honest, those principles weren't there from the beginning, and I want to give you one bonus round here. As an agile company, as we already said, we use something that's called the Deming cycle in order to create those things. They weren't there, also all three principles weren't there from the beginning. We started with containerization. Then we took around in the cycle, so we did containerization, we checked if it's enough for us, we evaluated if we needed to act, and then we found out, okay, we need to do something with the infrastructure, we added Terraform to it. We started a new cycle, we planned for it, we used Terraform, we checked for it. Was it enough? No, it was not enough. We had also had to add this monitoring and auditing process. So if you think you're agile, it's not just because you use Jira, but it's because you always go in the cycle of trying out and changing the things that you do. Last but not least, if you're looking for a job, you might be welcome at our office in Graz. And if you consider getting into an adventure with us, if you find it interesting what I have talked about earlier, go to denovo.at/karriere or send us an email if you have questions about any of the topics that I raised together today. If you're located in Graz, come to our office, have a coffee with us, have a chat with us. So this brings me to the end of our journey today. I hope I could give you some inspirations or an idea what you can have a look at next. Would be great. And maybe we can continue our journey together if you come to the Nuvo. Thank you.